Hello friends, very good morning. Myself Dr. M.A. Channaya, and in today's video we are going to work out a problem on the projection of a pentagonal pyramid. And let's see what is the question we have for today's video. The question reads like this: a pentagonal pyramid of side 30 mm and axis 65 mm long rests on HP on one of its corners such that the vertex is 50 millimeter above HP. So we have to read the question step by step. And first of all, our aim is to see that the object is correctly placed in its initial position. Now friends, you can see here, it is resting on one of its corners on HP. So very obviously, we have to place the object on HP such that one of the base corners of the solid is to your right, or one of the edges of the base comes to your left and it is normal to VP. So friends, we place the object, that is the pentagonal pyramid, on HP with one of the corners coming to your right or one of the base edges, say AB, is to your left. Obtain the front view to the given height and the top view a regular pentagon having side measuring 30 millimeters. So this is the initial position of the object. We get in the top view a regular pentagon with all the sides of the base joined to the corners, and we obtain this figure as shown. So friends, this is the initial position of the solid, and now we can project all these lines to the front view and obtain the front view, and these points on it are A dash, B dash, this is C dash, this is C dash, this is D dash, and this is point E dash. O dash and O1 dash represents the axis of the solid. Now friends, these points you have marked in the top view and front view, and this position is very important and it has to be marked correctly. Even numbering of the corners and the slant edges should be done correctly. Friends, you can see here that the vertex of the solid in the front view is represented by O dash, which is at a distance of 65 millimeter from HP. And in the question it says the vertex is to be at a height of 50 mm above HP. So we have to tilt the object to the right such that this vertex is 50 millimeter above HP. So I will show here, I just mark a line at a height of 50 millimeter above HP and obtain how to draw this, friends. Now friends, you are going to redraw this figure number 1 as figure number 2 here, such that this O dash should be at a height of 50 millimeter above HP. So the figure we draw here is A dash, B dash is the base of that, this is D dash, this is C dash, E dash, this is the axis center, that is O1 dash, center of the base. So how to construct this, friends? Now we can take some point at random and draw a line of this length O dash, D dash here. Get this point and you can just draw this taking the distance of the base, that is length of the base. And friends, after obtaining this front view, that is after redrawing this figure 1 as figure number 2 with the vertex at a height of 50 millimeter above HP, we are going to obtain the corresponding top view. So you can see here, friends, this line O dash A dash, O dash B dash are visible in the top view. So let us take these points one by one. Let me start with A and B. Draw a vertical line from A dash, a horizontal line from here. The point where those two intersect is point A. Similarly, you get B on the same line. Remember, this AB and this AB will have the same dimension because that edge is perpendicular to VP. Look at this point D here, and this is the vertex O, and AB, this is point C. We follow the same procedure and obtain all the 5 corners of the base. And friends, here we find the axis of the solid. You can show the axis also. That is point O1. Now friends, let us see which are all the edges which are visible to us. Excuse. The slant edges OA and OB, that is O dash A dash and O dash B dash are visible. So I will show them by a full line. So O dash A dash is visible, and here this OB is also visible. This edge AB is also seen. And friends, you can see these edges C and E, that is OC and OE are also visible to the observer. When they are visible, even these edges are visible. So these are the visible edges of the solid. Then friends, you can see when you are looking from the top, the corner D on which the object is resting is not visible in the top view, and hence all the lines connecting D are not visible. That is to say, this DE not visible, DC is also not visible, and this ODE is not visible from the top view. And hence I have shown this edge of the base, second edge, and this slant edge are not visible. Hence I have shown them by the dotted lines. Now friends, what is the next part of the question? In the next part it says, and its side opposite to the corner is parallel to it, means parallel to VP. So it is resting on corner D. The side opposite to that is AB. So that AB has to be parallel to VP. In this top view, AB is normal to VP. Finally friends, I am going to redraw this figure in the top view. That is figure number 3 as figure number 4, which is exactly identical to this. Only the thing is, here this figure is redrawn by keeping this AB, which was perpendicular here, as parallel to it. So friends, I am going to get figure like this. This is A, B, C, point D. This is E, and here you have got that point O1. This is O, the vertex. Friends, remember, figure number 3 and figure number 4 are exactly identical in all respects, excepting for the orientation. Similarly, figure number 1 and figure number 2 in the front view are exactly identical, and this condition is applicable even for the laminae, that is the plane surfaces. Friends, you have got the final top view. I will say TV here, and after that I have to get the corresponding front view. So let us obtain the point, friends. Let us start from the point A. Draw a vertical line from a horizontal line from there. The point where those two intersect is A dash. Similarly, a vertical line from a horizontal line from B, sorry. The point where those two intersect is B dash. So you got A dash, B dash. Then you got C and E here. This is point C and this is point D. So point C and D we have got are dashes. In the front view, they are shown by dash. This point is D. A, B, C. This is D. And this point is E. Friends, O. Draw a horizontal line from O dash, a vertical line from O here. The point where those two intersect is that point O dash. Friends, you have got all these points now, and let us join all these by straight line. So here OE is visible, OC is visible. So O to E, I am going to this OE slanted is visible. So I will show by full line, and this OC is also visible. A full line. These borders of the figure are visible. Show by full line. And friends, this D is here, and this D can also be seen that I have shown here as D dash. And friends, this slant edge OD or O dash D dash is also visible. And what is not visible is that base edge AB. So friends, that base edge AB I will show by a dotted line. So I've joined A to B, B to C, C to D, D to E, and E to A. And this is how, friends, the figure looks in the end view. And one more thing you should remember here, the object is resting on the corner D, and these two base edges, namely D, D dash, E dash, and D dash, C dash, they make equal inclination, say alpha with the HP. And friends, this figure will give you the front view of the pentagonal pyramid resting on the corner, and you have seen all these points, and you can verify the solution. And before that, let's see what all that is asked in this question. We have been asked to determine the inclination of the axis with HP. Friends, look here. Axis is O dash, O1 dash. Inclination of the axis with HP means this angle. So after construction of this triangle, if you project this line, you will get this angle. That's the inclination of the axis with HP. Next, the distance of highest edge from HP. So if you see the second figure, the highest edge is A dash B dash, which is opposite to the corner D on which it is resting, and then you can find out what is the distance between this A dash B dash and the XY. This distance is same as this distance. And friends, next we have got the inclination of base with HP. In the second figure, A dash, B dash, C dash, E dash, D dash represents the base of the solid. Right on here. This is the base of the solid. And what is the angle made by that base with the HP? So if you call this angle as some phi, phi will give you the inclination of the base of the solid with the HP. This line with the x-axis will give you the inclination of the axis of the pyramid with HP, and the distance between A dash, B dash and XY will represent the distance of the highest edge of the base. And friends, this is how we arrive at the final solution for the given problem, that is the pentagonal pyramid resting on a corner on HP. Friends, I hope that the presentation was interesting. If you like this video, please share this video with all your friends. Have a wonderful day, and I thank you very much for watching my YouTube video.